Hello everyone, myself Manjusha Sanap, Assistant Professor from Shivajirao S. Zondre College of Pharmacy, Asangaon. Today's topic is flame emission spectroscopy, that is atomic emission spectroscopy. It is also called as a flame photometry. Flame emission spectroscopy is also an analytical technique that used to measure the concentration of element in sample. Flame emission spectroscopy is so named because of the use of flame to provide the energy of excitation to atoms introduced into the flame. This is the principle of flame emission spectroscopy. The ions which is present in the solution by aspiration or they converted into aerosol form by using a nebulizer. Then it is that aerosols are then vaporized in the flame, so they generate the molecule. Then after providing the heat or thermal energy, the thermal dissociation is occurred in the flame, so there is a formation of ground state atoms. As that ground state atoms absorb the energy from the heat, they get excited, and that excited atom then emitted the energy in the form of light. This is the principle of working of flame photometer. These are the processes that are involved in the principle of flame photometer. Dissolvation. The metal particles in the flame are dehydrated by the flame and hence the solvent is get evaporated. Vaporization. The metal particles in the sample are dehydrated. These also lead to evaporation of the solvent. Then atomization, reduction of metal ions in the solvent to metal atoms by the flame heat. Excitation, the electrostatic force of attraction between the electrons and the nucleus of atom helps them to absorb particular amount of energy. The atoms then jump to the excited energy state. As the atom excited, that is at higher energy level, it is unstable, and then atom jump back to their lower energy state, that is the ground state, with the emission of energy in the form of radiation of characteristic wavelength, which is measured by photodetector. The excited atoms decay back to lower levels by emitting a light. Emissions are passed through a monochromators or filters prior to detection by a photomultiplier tube. So, the alkali metals are easy to excite by flame. For example, these are the some elements and they provide the type of flame or emission. Lithium provides the red flame, that is the red emission. Sodium, yellow emission. Potassium, red violet emission. Rubidium, red emission. Magnesium, blue emission. Now the instrumentation used for flame emission spectroscopy. It is also called as a flame photometer. As that of atomic means as at that of atomic absorption without the presence of radiation source. So this is the instrumentation. There is a excitation source, then wavelength selector and detector. So excitation source is used to excite the atoms. In flame emission, the sample is atomized and the analyte atoms are get excited by using a excitation source to a higher energy levels. These are the different components of flame photometer as follows: burner, that is a source; atomizer for atomization of molecule or atoms, formation of atoms; monochromators, detectors and readout device. Burners. The flame used in flame photometer should possess following functions. The flame should have ability to evaporate the liquid droplets from the sample solution in the formation of solid residue. The flame should decompose the compounds in the solid residue, resulting in formation of atoms. The flame must have the capacity to excite the atoms form and cause them to emit radiant energy. So flame is used as a evaporating source also. It is also used as an excitation source, and they excite the atoms to a higher energy level, and then that they come back to their ground state, they emit the radiant energy. These are the different flames in flame emission spectroscopy. So potassium their working range is 766 nanometer, and the color that observed for that flame with potassium ions, it is violet. Lithium ion, if lithium ion is present in the flame, then it produces the red flame. If calcium ion is present, then it produces the orange flame. If sodium ion is present, it provides the yellow flame. Barium provides the lime green color. So these means according to this color of the flame, we can detect the elements which is present in our sample. Then different types of burners are used to generate the flame. So maker burner, total consumption burner, laminar flow burner, it is also called as a premix burner, Dondergraph burner, shielded burner, nitrous oxide acetylene flame. So from this, all of these two burners are maximum use, total consumption burner and premix burner. So what is total consumption burner? So in this burner, the fuel and oxidants are hydrogen and oxygen gas respectively. In this, the sample solution is aspirated through a capillary by the high pressure. Fuel and oxidants are burned at the tip of the burner. The name total consumption burner is used because all the sample that enter the capillary will enter the flame regardless of the droplet size. Therefore, it is called as a total consumption burner, because the total sample which is entered, it get consumed. So advantages of this burner, their design is simple and entire sample is consumed in this burner. Disadvantages are uniform and homogeneous flame is not obtained, since droplet sizes vary and they leading to fluctuation in the flame intensity. Means overall detection or in overall process, there is a not uniform flame is produced, or flame intensity is not uniform. They may produce the fluctuation. Laminar flow burner. So this is the diagram of laminar flow burner. So sample is entered with the capillary, then oxidant and fuel gas is entered through different tubings. There are some baffles, and these baffles are used to premix the sample as well as oxidant and fuel. So therefore it is called as a premix type burner. So then all these three are provided at the flame at a time. In this type of burner, aspirated sample, fuel and oxidants are thoroughly mixed before they reach the burner opening, and then they entering the flame. Important feature of this that only a small portion of the sample reaches the flame in the form of small droplets and easily decompose. Advantages: premix burner is non-turbulent, noiseless and stable. Easy decomposition, which leads to high atomization. It can handle solution up to several percentage without clogging. Then demerits: when it contains two solvent, more volatile will evaporate and lesser will remain undissociated. So more after the flame or after the excitation sources, means flame emission spectroscopy, the excitation source is flame is used. After this excitation sources, the next one component is monochromators or filters. In simple flame photometer, monochromator is prism. Quartz is the material used for making the prism because quartz is transparent over an entire region. Then filter. The filter is made up of such material which is transparent over a narrow spectral range. When filter is kept between the flame detector and radiation of the desired wavelength from the flame will be entering the detector and can be measured. The remaining undesired wavelength will be absorbed by the filter and it is not measured. In flame photometry, the wavelength as well as the intensity of radiation emitted by the element has to be monitored. Hence, filter or monochromator is used. Detector and readout system. The light selected by the monochromator is directly onto a detector, that is typically a photomultiplier tube, whose function is to convert the light signal